I'm Karl. I'm here to talk about practical solutions to detecting bugs. We would touch upon implementation details, tooling, and process. So a little bit about me. I'm from Sweden, if you can hear. I have a small accent. I got offered a job in San Francisco around in 2004. And since then, I worked at a couple of companies, Guild being one recently, and now I'm at Quartet now as a lead software engineer. I've been there around 9 months. So what is Quartet then? Quartet is a behavioral health technology company that's improving the mental health space. Why we're doing that is because, as you see here, 1 in 4 Americans experience a mental health disorder in the last year. So the issue we're trying to solve is connecting these people to a behavioral health therapist. So what we do is we deliver a scalable behavioral health platform. So what that means is we take the doctor's patients that we identify as having a mental health issue, and we're matching them with a provider, behavioral health provider in their area based on these issues. And with that, on the other side of that, we are providing a collaborative platform for them to work together, basically. So building this product, there's a lot of stuff that needs to be working and can't fail because we're dealing with people's lives, and it's like important stuff. And also we are working with a lot of sensitive data, so we need to make sure that our systems are reporting and detecting issues as soon as possible. So how do you know that something is wrong in your system? Well, let's catch some errors. So there's also there is this assumption of like you coding something and you're like, okay, this is fine. It will never like reach this like other state. It will never like hit this other else statement. But what if there's always like you have too much faith in your data model? It can get corrupted. It could happen like anywhere. So identify those issues and start logging when those happens. Another good practice to do is to wrap logical pieces of code in try-catch statements, and you log the errors basically. You should try and do this as often as possible in the pieces of logic that you feel is doing something. Yeah, it's kind of self-explanatory if you're a programmer. The third thing is to use metrics. In this case, we just have we're detecting the login if it's successful or it failed, or we have a backend error when you person logging in. So these are one example of metrics, but you're gonna use metrics for a lot of other things also. So that's for the code part. You need to measure environments also to make sure your code or your instance of code that you're running is not using too much CPUs, too much RAM, it doesn't spike, etc. Disk space is a crucial thing people overlook a lot because they're just writing these big log files and suddenly like, oops, we run out of disk space. So once we have done all the logging and we're doing all the measurement, we need to create some sort of alerts, right? So in whatever logging software where you're aggregating all this data that you're logging and all the metrics that you're using, you need to be able to create alerts based on search queries. They could be Kibana, Sumo Logic, whatever your flavor is at your company. Metrics is really good to detect trends. I like to call them like negative trends where you can actually like identify, oh, we didn't have any logins for the last 24 hours. Or, oh, we didn't like have any orders for 24 hours. Something is wrong, but we're not detecting it through like errors. There's like a trend here that's not good. And also externally, like if you have a customer base or employees using internal tools, they should be able to report issues. Once you have all of these alerts created, we need to organize them so you don't get overwhelmed with a wall of just noise, basically. So one way to do it is you can add tags to alert, saying they're like tagged to a specific team or a specific functionality area. So that's one good way to organize and group them. There's always good to have like some sort of naming convention with the tags, because otherwise it's just derails and you have all these tags and it doesn't actually help you that much. This totally depends how your log messages are structured, by the way, and what logging software consumes those log messages, so you can search upon them. But most of these softwares support these, like objects in the log messages, so you can parse. So the last thing is with the alerts is like once one get triggered, it should create a ticket in some system where you are gathering your work in. So the ticket should directly get associated with what service or what team is owning that piece of code that the error is happening in. So once that's set up, we need to communicate that an error happened or a ticket got created. So the software that creating the alert should also create a ticket in some sort of system like Jira, Fogbus, whatever you're using, and also communicate it in the tool that you're using the most to communicate in your work environment. Slack is probably the most prevalent here, and there's fully like integration with all sort of tools there. So this is like, so depending on the alerts, you also want to have it so you can configure in what specific channel, so the team that is supposed to respond to the issue actually responds to the issue, so it's not like everything just ends up in this same channel, because then it can be hard for anybody to see what's going on. So it's just funneling it to the right people. So at Quartet, the flow so far has been like, we log stuff, it ends up in our Elasticsearch that gets consumed by Kibana, and Kibana then uses a thing called ElastAlert, and ElastAlert issues a PagerDuty, and the PagerDuty creates a ticket in Jira for us, magically. So once these tickets are created, like you have all these tickets, like what's going on? We have a terminology called on-call. Other people might call it like red hot, on duty, whatever. This is a person that looks at this queue, basically, of tickets created and responding on alerts, saying like, okay, I seen this, I'm looking into it. Yeah, so this is what I talked about. So once the on-call acknowledge the issues, the on-call person doesn't want to be on-call forever, right? You have to rotate this role among your team members. So depending on the team size, you might have a weekly rotation or bi-weekly or whatever fits your organizational model. For us, the Jira tickets gets actually assigned to the current on-call person, so this is a nice feature. So you get like notice. You get identified pretty immediately. So this is an example of like our weekly rotational schedule. No surprises, people might recognize this screenshot from PagerDuty. That I'm not sure if there's any alternative that's up to par right now, but we use it heavily. It costs arm and a leg, but we're fine with that. So as I said, so the primary on-call receives the alert, acknowledge it through the same channel they received it. So you basically, in Slack, whatever tooling you're using, you should be able to acknowledge the alert also. A lot of people have the PagerDuty app on their phone and can accept it that way. a good thing that we're doing, we have primary and secondary schedules. If you're not available, it gets bumped to the secondary. And that happens within 15 minutes for us because we need to be able to respond pretty quickly on these things. So once you acknowledge and you know that the issue is happening, you need to respond to it and like make sure like, what kind of level is this alert? Should I work on it now? Should I work on it later? Should it be assigned to a different team? And also, there's this thing you can do with specifically in PagerDuty alerts. You can assign what you call a handbook link, where it's actually links to a documentation where you can have detailed steps in how to identify the issue. This is also like, this is a process that the tooling, PagerDuty specifically has this where tickets are open until they're acknowledged and resolved. So depending on the frequency of issues and the status of them, you might want to have them open or just resolve them pretty immediately. It all depends on identify the issue within like the first couple minutes, click on the handbook link, okay, this is the same issue as before. I just go ahead and resolve it for now, make a note in it, etc. Yeah. If there's like a employee, should be customer there. If it's a customer or employee filing the issue, you need to have a different process how to respond. You have to have like a communication to them saying like, okay, we're looking into this issue. Whereas like the code doesn't care if you are looking into it. It's just telling you over and over, I have a bug. But so depending on the customer and depending on your SLA, you might have to respond in a certain way with a certain time frame. We have this a lot because our companies that we're working with is insurance companies, and we have to often write SLAs with them and give them reports later on what the performance is responding to these things. So through the 9 months I've been at Quartet, there's been some on-call best practices established. This is probably the most valuable part of this talk. So we have established process and guidelines. We have created a document that outlines like these are the things that as your employee, when you're on call, before you're on call, these are the things that you should like do. Like you should have the PagerDuty app installed on your phone. You should be on an on-call rotation. You should know what apps your team are responsible for, et cetera, et cetera. This is always good to have a document like this, outline it, doing the onboarding process, they can go through it so they get information about what duties you have as an on-call person. So these are some direct guidelines that we have in our document. If you go on vacation, you notice that I'm supposed to be on call when I go on vacation. It's your responsibility to figure out the override so somebody else takes your role when you're out. Each team is responsible for creating their own PagerDuty alerts or integration with PagerDuty for the services they own. There's no separate team to take responsibility for this. This is a really good one we started recently. And it's about once your time as on-call is over, the next person going on, they need to know what's going on. So we have a meeting where we have a report, the same report we give to our insurance companies or external partners, telling them what we resolved and what issues we encountered that week, basically. You go through this report, you talk about the issues that you resolved, you talk about the issues that are still ongoing, so they know what's going on, so they're not getting like surprised going on for a week. So how did did Quartet get there? So one thing, the whole talk basically, I started thinking about this talk because there was a lot of noise in the beginning. There was a lot of alerts going off. There was a lot of misconfigured alerts. There was a lot of bad search queries. So we needed a process. We needed some things to like help us out, so you don't spend. So not everybody spend a lot of time like trying to figure out how to solve this stuff. So there's some. If you see that an error happens like all the time, every 5 minutes, it's probably like something that shouldn't be an alert, or if it is, fix it pretty quickly. You can downgrade the alerts to warning, or you start issuing metrics because you're okay, this is fine to have this error, but we should only like alert like if it's like happening way too often. Another good practice is that the on-call should be dedicated 100% of the time to just on-call work, to fix a bug and responding to alerts. Because otherwise they will be distracted between trying to get their sprint tickets done and at the same time fighting fires. And that's not a good combination. On the good side is that once there's not that many alerts happening or like fires to fight, you improve the process. You add more logging, you identify more pieces of code we can add metrics to, and just so you have better insights in the health of your systems. So tools love processes. You can't just get a tool without having a process around how you're going to use it, because otherwise there's no utility in that tool if you don't have a process around it. This is actually, the quote is here, I don't know who, but my old CEO used to say this a lot. If you only have a hammer, everything looks like a nail. So you have to have a process around using the tools. Yeah, that's it. Thank you for your attention. Questions, yeah.
What's your stack?
So we have there's a React on the client side, and then we have a Node backend. And the Node backend talks to a service, an open graph language that we created called Moyo. That's using a database layer that's atomic that sits upon MySQL. Logging is just, logging is an interesting thing because we are sending, because everything is containerized, so we're sending the logs to SD out or SD errors, so we don't have any log files, because if we deploy something new, that logging disappears in that container. So we're just basically having a process that listens to the running process, and then we pipe that directly to Elastalert, or Elasticsearch. And then we have Kibana over that. So.
Let's see. Any questions from the group? You also have this cool little box thing. I've seen it before. It's a microphone. So
neat.
Questions.
It's like heads up. Yellow box come flying.
Did you evaluate things? Oh, actually, it is a microphone. This is amazing. Did you? I thought you were lying. Did you evaluate things like New Relic, or have you ever heard of Honey Badger? That's another
yeah, so we actually experiment with New Relic. New Relic, I don't know. First, I know the support for JavaScript and Node apps, how well they integrate with them. But I know old company, we use it a lot with the Java and Scala stacks, and you get a lot.
Yeah, the only reason I asked was just that they have like an agent that runs on your application side that will just record every time the server throws up a 500 or something.
Yeah, so that's, we do that on the server side. The client side is a little bit trickier to report errors on, right?
Right, yeah.
Because we were using, it's more about, we're using it's a single page application. So it's like a big application. This React app that's running and just it does HS calls. So it's just whatever the API throws errors, we need to capture them, and that's in the node stack.
All right. Any other questions? One I had for you was a little bit of problem.
Quick.
Lucky that didn't hit me in the head. It's kind of related to something I just heard. You mentioned you're using Elasticsearch and Kibana. Are you managing that server yourself, or are you using something like AWS's?
We use the AWS.
Okay. Quick technical question, if I can ask.
Yeah.
Security between that and your environment, AWS offers obviously the usual stuff where you can just specify an IP address that is allowed to communicate with it, or it also allows you to do like signed requests.
We have signed requests, and they're on the same VPC, I think. I'm not on the infra team, but it's definitely secure because we have PCI and HIPAA compliance. Like.
Right. I might grab you after then.
Okay.
I won't get into details.
Last question for me is, who decides that when an error is of the severity that requires immediate assistance from the on-call team? So who makes the call about what the threshold is?
That is discretionary based on the team member that's looking at the issue at the moment. And the team member also is, what's important to point out, is empowered to pull in anybody who might know more about why that issue is happening. So you can just, if they're in a meeting or whatever, like you need to grab them, you grab them because you're on call. So that's a cultural thing that we established also. Like, there's something wrong with this service. I'm calling another service and I keep getting errors from it. Like, why are not you detecting that error in your service? Like, let's figure this out pretty quickly. So.
Cool, Karl, thank you very much. That was awesome.